Our next topic is dimensional analysis. This is a very important topic in the class, and we will use it often throughout the semester. The details of dimensional analysis from your notes. The dimensional analysis method uses equivalences written in fraction form. Because the numerator and the denominator of the fraction are equivalent, the value of that fraction is 1. We know that multiplying by 1 does not change the quantity, but using an equivalence will change the units or the label. In order for this to work out, the units must be in opposite parts of the fraction. So that means 1 on the numerator, 1 on the denominator. Let's start by looking at just multiplying fractions to see how this all works. So if we take a fraction, say 2 over 5, and we decide to multiply it times 3 over 8. How do we multiply fractions again? Many people get confused on this. In order to multiply fractions, you multiply straight across. People want to mix this up with proportions. We'll do them later in the course. But with fractions, straight across. So, for this problem, we would want to multiply the 2 times the 3, and when we do that, we would get 6. And then we'd multiply the 5 times the 8, and we'd get 40. This, however, is not a great answer because both 6 and 40 are even numbers, so we need to reduce this, and we can do that by taking out a common factor of 2. So if I divide the 6 by 2, I get 3, and if I divide the 40 by 2, I get 20. So this is the same as 3/20. Now, that fraction is fully reduced because 3 and 20 have no common factors. Some of you may have noticed back here at the beginning that there was a common factor between the 2 and the 8, one on top, one on bottom, or in opposite parts of the fraction. Because of that, I could simplify from the beginning, taking out that common factor of 2 from both of these numbers. Now if I multiply straight across, 1 times 3 is 3, and 5 times 4 is 20. And so I go directly to that final answer. So let's take a look at a very simple example with units, because that's where the dimensional analysis comes in. This one is so simple that you could do it in your head, but we're going to set it up so that you see how it all works. So 2 feet is equal to blank inches. And you could fill in the answer of 24. If I would measure something 2 feet long, or if I would measure something 24 inches long, they would be the exact same length. So that's this part about multiplying by 1 does not change the quantity. Our length does not get longer. But by using equivalences, we will change the units or labels. So in our notes, it tells us that we must use a fraction. So the first thing I have to do is make 2 feet into a fraction. You can make any number into a fraction by putting it over 1. So 2 feet over 1. Then it tells me I need to multiply by an equivalence. The last thing we wrote is that the matching units to cancel must be in opposite parts of the fraction. Here feet as a label is in the numerator, so I need to write 1 foot in the denominator, and I know that 1 foot is equivalent to 12 inches. So the labels of feet cancel. The label of inches will not cancel, and it is actually the label that we want, so I'm going to circle that. So then, how do we multiply fractions? Well, we multiply straight across. So I have 2 times 12, which is 24. In the denominator, I have 1. 24 divided by 1 is indeed 24 inches, just like you knew from the beginning. So let's try a little bit harder example, one that we probably can't do in our head. I'm going to be switching to our content guide, and we're going to work through the first problem, which is converting 14 gallons into liters. In order to do this problem, I start out by making 14 gallons into a fraction. And I can do that by putting it over 1. Now, I'm going to look on the back of my pre-lecture sheet. I'm looking for something that has a label of gallons because I can use that to cancel the label of gallons. And when I look carefully, I find that 1 gallon is the same as or equivalent to 4 quarts. So using this equivalence allows me to cancel gallons. But I'm not done. Quarts is not the answer that I want. So I have to look again. This time I need the label of quarts to cancel, so that's got to be on the bottom in order to cancel. So I look and I find that 1.0567 quarts is the same as 1 liter. This allows me to cancel the label of quarts, get to the label of liters, which I'm circling because that is the label that I want at the end of the problem. So I'm ready to do the math. We're going to multiply straight across. So 14 times 4, hit enter. So the top of this would be 56. I can jot that down, but I don't really have to. I can keep going. On the denominator, 1 times 1.0567 will be 1.0567. So I'm going to divide by that amount. And I get my answer. Now, my math lab, where you do your homework, will give you directions on how to round your answer. Please follow the directions. Here, we'll say that this is approximately 53 liters. When you get to your quiz next week, I will give you the equivalences, so you're not having to memorize the information on the back of your pre-lecture sheet. However, I am looking for you to set the problems up using dimensional analysis. So the setup is the most important part. Even if you could get the right answer by another method, you would not earn full credit. So as you work through homework this week, please make sure that you're practicing your dimensional analysis.